afternoon to all. My name is Hetal Prajapati, Head of the Diploma Electrical Engineering, Parul University. Today we have the webinar on electrical safety. So let me introduce today's our expert, K.D. Kavaiya sir. So K.D. Kavaiya sir is a chartered engineer. He has started his first job at MS Jyoti Limited in Switch Gear Engineering Department. He has also joined GEB in 1979 as junior engineer at Nadiad in construction subdivision. He has worked from 1985 to 1997 as deputy engineer at 210 by 6 megawatt thermal power station, Banaguri. He has also worked as commissioning engineer of Unit 4 and maintenance engineer of Stage 1 at Vanaguri. Sir has a key role in safety aspect of power stations. At GEB Corporate Office, Vadodara, in inspection department, they have worked also from 1970 to 2007. So, sir has worked as a head of transmission division, Gotri, Vadodara. They deliver lectures on electrical safety at GetCo, Gotri Training on Safety. He has also worked as visiting faculty at Gujarat Safety Council, Vadodara. Sir worked as an associate engineer with Tapalkar Power Engineer and Consultant Limited, Vadodara. Mr. K.D. Kavaiya sir has got rich experience of substation, transmission lines, power station, inspection and executive role in safety aspects. He has carried out energy audit at various industries in Gujarat including safety audit. Sir has executed live line earth wire replacement by OPGW project, work on 220 kV Morbi Lalpan line and 220 kV Kesod Sapar line as safety engineer. So we have for next 1 hour we have very good expert on safety, electrical safety. So I request all the viewers to be with us for next 1 hour. Now I would like to over to our sir, K.D. Koya sir. Please begin your presentation.
Yeah. So good afternoon to everyone. So am I audible, everyone?
Yes sir.
Yes, sir.
Okay. So in fact, I'm really happy to join you people. Especially, I congratulate everyone, your faculties as well as the students, because I know earlier we were never getting any chance to go for any uh, this seminar or lectures or anything, and sometimes if we required, we had to pay. Even as of today, also I am paying my fees for attending certain seminars. But you students are very much lucky because of your uh, head of the department, your professors, and your college, university, that you are getting an advantage to have webinars like this. And I'll tell you, this is the most important subject in everybody's life. I'll say not electrical safety, but safety as a whole. It's the most important subject in everybody's life. And the safety starts right from the pregnancy of a woman, and when a child gets born, and up till whole life, every step there is a safety. We may not know because it has not been distinguished which step we are taking. But again, everywhere, when the child is very young, so mother takes care of her. Again, when he grows or she grows, again parents take care of her. Like that, throughout the life, safety is there. But here, the subject, electrical safety, mechanical safety can be understood by having vibrations, very noise, and some cracks or anything. So if the fan is having some problem, then the sound of bearing will be different. So you understand there is some problem in fan, some motor are running. So you can make out there's something wrong, and it may give away and may have a problem. In civil, you must have find some bridges are there. So if some cracks are there involved, some cracks are there. Civil engineering also, you can see that there is a danger. Mechanical danger you can visualize. Civil dangers you can see, but electrically something which is a hidden one. So just like a serpent or that scorpio. If it is in some basket, then you cannot touch it because you never know when it will bite. So just like that, electricity is something which you never know whether it is passing through something, doesn't pass through, because you can see simply wires. You can simply see the wires, but you never know whether it is dangerous to touch it or not. So, electrical safety is the most important thing. I think yesterday only you must have seen that in Iraq, in hospital, COVID hospital, there was a fire. Fire because of what, you know? In India also, in Surat, Bhavnagar.
Sorry to interrupt.
Yeah, yeah.
Your screen is not visible, sir.
Is it?
Yes, sir.
Just hold on.
Yes.
Screen not.
Screen sharing is not done, sir.
Okay,
That's right.
that's good. That's good.
Yeah. Okay, sir.
But this presentation sharing my screen.
Yes, sir.
Okay, so you can see my screen, right?
Yes, sir.
Okay,
Now it's visible, sir.
okay. So the thing is, um, uh, electrical safety is something which is very hidden. And as I told you yesterday or day before yesterday, there was a fire in COVID hospital in Iraq, in Surat, Bhavnagar also in COVID period, especially COVID hospital. There were fires and people got burnt and mid to days also. You know why that fire occurred? It is a short circuit. Short circuit, a number of oxygen cylinders coming in play, and that was the resultant of short circuit, face to earth, face to face, and that has resulted in uh, so much fatality. So electrical safety is that important. So one has to be very much careful about it. So I'll just start my presentation, and meanwhile I'll be also just sharing certain things, right? Okay. So I'll start my presentation. So electricity is not simply the thing which has come in place. In earlier, electricity rules were there in 1956 for electrical installation. Then after the same were again modified, and Electricity Act 2003 was passed. This our Central Electricity Authority regulations also came in force in 1956. Earlier, then it were again modified. Then technical standard for the construction of electrical plants and lines regulations 2010 came in picture. Then measures relating to safety in electric supply also, the regulations were there in 2010 and 2011. Then standards for electrical safety in employers' workplace. So wherever the people are working, there are some standards. So if the people just act or do their job as per the standards, there will be hardly any incident. So the standards are there, but people are not following, or those who are in charge of that, they are also not making the people to follow, right? So safety, if someone goes as per the standard procedure, there will be hardly any chance of any incident. So safety is the inherent spirit of developed human being. The safety is integrated concept of teamwork of one and all personal department. See, if one worker is doing his work as per the safety rules, and doesn't his colleague is not following, so it does not mean that safety is all occupied. So what I mean to say, right from the management, top management, to their again officers, then supervisors, then workers, it's a teamwork. And every company, most of the company has got their own safety policy. So after making it's a government statutory requirement. So after making the statutory requirement, safety policy is being formed by each company according to the nature of plant. Nature of plant means some may be chemical factory, some may be industrial, some may be electrical factory, So like that, as per the nature of the company, the safety policy is prepared. So now, most basic thing, all students are electrical, studying electrical. So most basic thing is a complete circuit or loop is necessary for a current or law. If some, uneducated person, if you want to explain them, then see, this is a simple our battery. So if you connect it with some electrical gadget, and then you switch on, so the current will flow, and once the current will flow, then so this installation will start functioning. Just like all, this is the most basic thing. Electrical can be understood by any uneducated person also. So in generally in a single phase, there is a live wire, always with a red color wires. Then there is a neutral, and there is a earth. So when the circuit is complete, then say fluorescent bulb or any other function, it will function. So if it is a bulb, it will glow. If it is iron, it will get hot. So like that, and earth is in all matter, all the instrument, all the articles, all the equipment, wherever there is a metal in that installation. So earth is the thing which will protect the equipment as well as the persons handling it. So many a times we see the birds sitting on a conductor, overhead lines, and we people get surprised why the human being is getting shocked, but why not the birds? Because here the circuit is not getting completed. It may be having the connected this power, but it is not getting the earth. So circuit is not in a loop. So that is the reason a bird, even in sitting in low tension line, they are not getting electrocuted and they don't die because the loop is not completed, right? Complete circuit is necessary for the current to flow. So see this fellow, this is not a high tension line, it's a low tension line only, low voltage line. So when he's touching this thing, so again, he is not on the ground. So simply electricity is not getting the path to complete. So he doesn't get the shock. But here the case is what, he touches this electrical conductor, then his foot, his legs are on the ground. He is a barefooted man, so naturally he will get a shock. He will fall down. So electrical shock, one must understand very well how a person gets electrical shock. So again, as I told you earlier, it's a line. Then just to break it, there is a circuit breaker fuse system, and this is our electrical installation. It may be a fan, iron, electrical tube, or anything. And when it is connected with a neutral, and we give the 230 volt supply, this will act. This is a load, and it will give its function. Bulb will glow, iron will get heated, heater will be getting heated. So this is the most basic circuit everyone knows. Here, here again you see this earthing. Earthing is connected with this device. So naturally it's in backup. Backup earth. When any system is backup with earth, neutral is earth. So this helps in protection of the equipment as well as the protection of the human being. So earthing is the most important in electrical, and it should not be a loose earthing. It should not be broken earthing. So in electrical mind well, earthing is the most important factor. You know. So again, in the same line, this is our alternative current source. So when current flows, and this is load. So as long as the load is functioning, current will flow like this, and this electrical thing will be functioning, either it's a motor, fan, or anything. But if someone touches it, if suppose this is a wire, insulated wire, and suppose insulated wire is damaged, cut, or it is open. And if you touch this live wire, whose insulation has gone, so if you touch that live conductor or wire, naturally you will be getting shock if you are on the ground. So ground is earth. Ground means is earth. And if you are not wearing any shoe, slipper or anything, naturally current always seeks the shortest resistance path. So human body is again conducting. So current will flow, the fault current will flow through this, and this person will get shock. This is the fault current because of some insulation is open, it is touching somewhere, so fault current will flow. Either it is in a wire or in this motor, pump, fan, winding or anything. So fault current will flow. When fault current, once it flows, the breaker, fuse, or it will get tripped. But during this fault current, if someone touches the equipment wire, then the fault current will flow through his body and he will get shocked. So this is the most basic things. Okay. Now, current, it's a flow of electrons. Resistance is used for the direct current measured in ohms. Impedance is the proper term for alternating current, but generally we use mainly we use the common word as resistance, and we say in terms of ohm. When you check with the multimeter, it is always showing milliohm, ohm, ohms in thousand, and like that, kilowatt, megawatt, like that. So mega ohm, kilo ohm, mega ohm. So in multimeter you will see this figure, ohm, micro ohm, milliohm, ohm, kilo ohm, and mega ohm. So generally we use this word resistance and we measure it in terms of ohms. So as said, live and neutral wires carry the current around the circuit. Earth wire is there to protect you. This is important, as you say. Earth wire can act like a backup neutral wire. Many appliances having metal cases, kettles, toaster, dishwasher, washing machine, they have their earthing terminal on their body. So body will be connected to the earth point, and earth point will be to our residence or office or our commercial complex, like that. But in some certain things, suppose the blower is there, it's a plastic body, so there is no earthing point on that. So it is not requiring to earth those things. Fuse in all the electrical circuit, this is always there. Fuse is for what? If the current is flowing more than the capacity of the source load point, then this is there to protect that equipment, so that the load, say if it is a motor, if it is your lighting, then if it is your another equipment, so they will be saved when there is a more than the required load or more than the specified load. So fuse, if it is a fuse, it is a switch, it is a breaker. So all these things are there to get the circuit broken. Once the circuit is broken, there will be least damage. So, so fuse should be always as per the rating of the load. A fuse does not mean you just put a thick wire to make the supply on, but that will damage your load. That will damage your equipment installation, electrical installation. So mind well, the fuse is important as per the capacity of the equipment to be used. So whenever there is a more current, the fuse wire, it melts and circuit gets broken. So appropriate fuse size and rating is most important. Now additional safety, it is by generally we use the ELCBs, earth leakage circuit breaker, miniature circuit breakers, residual circuit breakers. So all these devices are there in our use nowadays in all the new buildings. All the contractors and design people, they employ ELCBs, earth leakage circuit breakers, just to protect any human being from any fault current shocks. So electricity is, see, you must have seen your in house there is a plug socket, right? So unless you fix the plug pin, the current doesn't flow. So electrical current will not flow unless you put the load, because once you put the load, the current will flow. Electrical won't flow until there is a complete loop out from and back to the power source. So, just electrical engineering student, I do not know whether you people have visited any substation or not. I do not know. But in our GB, say MGVCL, there are 66 kV substations. From 66 kV substation, there are transformers, 66 kV to 11 kV transformer, step down transformer. Then from 11 kV, this step down transformer, there is a 11 kV bus. From 11 kV bus, there are number of feeders going to different parts of the area, say around the substation. This particular substation is at Atladra, is at Atladra. So you can see there are different feeder, 11 kV, this feeder, 11 kV Gujarat tractor feeder, 11 kV Karali feeder. This is station transformer. Station transformer means from this particular panel, the feeder goes to 11 kV transformer. From 11 kV, there is a step down to 415 415 volt. So from that, again, this particular substation gets supply. You know, this substation gets supply from the 11 kV station transformer. So lighting of this control room, switchyard lighting, then pumps put in substation, everything is getting power from this 11 kV station transformer. And this is an incomer. You know, incomer number two. So every substation, at least minimum there are two 11 kV main incomer. So see, from transformer, from 66 to 11 kV transformer, the power will come to 11 kV main 1, 11 kV main 2. So if there is a fault in this bus, see, there is a bus here. There is a bus here inside. It is on the back side. You can't see here, but there is a bus inside this. So if there is some problem in this breaker, it gets fired. So this 11 kV main 2 will trip. But in that case, supply will be resumed from 11 kV main number 1. So this is something basic. See, there are breakers here. Here there are meters, energy meter, ambient meter, voltmeter, and here there are earthward overcurrent relays. So this is the basic of a substation. This is a rubber mat. I'll show you use of it. This is earthing. This is earthing. Then there are fire extinguisher. They are the safety posters. You know. Now I'll tell you. See, the name of panel on the backside also the same name is affixed, so that if someone wants to take line clear on this feeder, he may not make mistake from the backside, because backside, suppose someone is working, then he will get shocked. You got me? See, if I'm taking line clear of this feeder, my person has to work on this feeder. So if someone says, okay, let me clean the backside of this also, in that case, instead of this panel, if he goes to this panel, he will definitely get a shock, he will die. So this is something you may not understand from these pictures, but on live, any substation visit, you can ask question, you can know what is the system, and if possible, if it is something feasible, your management and me, I can take you to some substation also. So here, see, this is a voltage meter, this is a power factor meter, this is a watt meter, emitter, and again there is a LED. See, when the breaker is on, it will have this indication, off, this indication. This is a trip circuit healthy. This is a switch to make the breaker on. It's a trip neutral close switch, TNC switch. And here, this one and this one, this is a voltmeter selector switch related with this meter. This is a ampere selector switch connected with this meter. Okay. and breaker is below this. Breaker is in this compartment. This is called metering compartment. This is called breaker compartment, and bottom is a relay compartment. And backside, I'll show you. See, again, I'll tell you. This is a meter compartment. This is a breaker compartment. What you see here is a breaker. So this is red is indication for breaker close. This is breaker off, and this is a relay compartment. On backside of this panel, this is a bus bar. This there will be bus bar here, and at below there will be a cable. 11 kV cables will be there on the backside of this part. Okay. So once any electrical accident takes place, there are three stages. It's a minor injury, major injury, and fatal accident. Fatal means one will die. Fatal means one will die. Or major means he will be having some burns. Sometimes he may lose his important head, leg, foot, or anything in fatal accidents. So the severity of electrical shock will result into the severity of body, right? So again, once some person is getting shocked or he will die, then his family will be suffering a lot. His company will be suffering a lot. There will be financial loss. And mind well, you can get so many things from the market, but you cannot get our body parts from the market. You cannot get your life from the market. So one has to be very careful about electrical dangers, electrical accidents, and one has to be very safe, alert uh, about all electrical things. See, now we study. See, we understood that electrical is a danger, but now what are the factors that will lead to an accident? You know, so when an electrical line or conductor is unexpectedly still live, suppose you have switch off your say electrical geyser, and uh, you are switch off, but actually the switch was faulty. So you are thinking that I have cut off my power, and let me touch the geyser or let me touch the wire, so you will get shocked. So what is the thing? Unexpectedly still live. So you may not be knowing it's live. So in this case, being a power not cut off, even though your switch off is off, you will get shocked. Okay. Once in substation, I'll show you. See, after you have cut off the switch, but isolator is not open. Isolator means switch is not open. Then it is not power is not isolated properly. There are three phase, So out of three phase, suppose two phase are isolated. Switch is cut off in two phase, but one phase there is a problem. It is not getting open, so it is not isolated. So this will lead to an accident. Power will be that. Now you must have heard you must have seen or read in newspaper that so and so figure GB lineman, MGVCL lineman or helper got shot. Why? See, in so many complexes, buildings, or industries, if MGVCL power is tripped off, cut off, then in that case they start their own generator. So once they start generator, if the switch of MGVCL power and their diesel generating power are not cut off, if they are not cut off, the power will go back to the MGVCL feeder line. You know, this is the reason why so many MGVCL helpers or linemen, line staff have got shocked, because some companies are uh, starting their generator once the MGVCL power is off, not getting power supply from MGVCL, they start their own generators, and once they start generator, power is back to MGVCL feeder line. So the person who is working on line, after making shutdown from substation, he will get shot. These are so many cases. Okay, then this is a natural one, lightning strokes. So lightning is a natural, we can't prevent it, But mind well, this is a monsoon season. So sometimes when it is a monsoon season and you feel that there will be rain and you go below the big tree, so which is already wet because of earlier rain. So don't stand below any tree which is wet one, because lightning, once lightning start, definitely uh, this tree which is already wet, it becomes a bit conductive, and once it is bit conductive, uh, uh, the lightning will seek the shortest path, so you will be affected. So mind well, in this monsoon season, don't stand or sit below any big tree which is already wet, right? Then induced current. Naturally, induced current, uh, is called induction. In induction, one big line is there, say 220 kV line, 400 kV line. The nearby portion is having induction zone. So then also persons get shock. So it has already been statistically observed that the most common cause of unexpected presence of voltage on electric lines or installation were due to mistake in operating switch, or operating switch itself may be faulty. So if someone has to, I'll show you. Uh, again back. Okay, if as earlier told you, if someone has to work on this feeder means it's a line, 11 kV line. Feeder means line. So when someone wants to do maintenance work on this feeder line, so substation people will make this breaker trip. They will take out the breaker out, so there will not be any power from this breaker to 11 kV line. But again, suppose there is in isolation, the switch is not cut off. Switch means isolation. Switch having three phase is not cut off, and maybe some induced current is there, maybe some leakage current is there, maybe some charge current is there, and immediately if someone goes on the line feeder, he will get shock. You know. Then mistaken identifying the work to perform. Instead of Kalali feeder, someone is switching off. Okay, if someone MGVCL person wants to work on this, but substation fellow, instead of this, he is switching off this feeder. He's taking breaker out of this feeder. So naturally, this feeder was live. This is a mistake, mistake, because nowadays in this thing mobile, people get line clear. Line clear means permit to work on phone. Of course, the code number is there. There are system not to have mistakes, but still, sometimes in hurry, this operator fellow, this substation is listening something wrong, then he will be switching off. Instead of this, he will be switching off this. So breaker of this feeder will be out. It will be tripped, but this will be live on which MGVCL people will be working. So they will get immediate shock. Immediate shock. Out of three phase, suppose one link is also partially engaged, means it is not open, then also power will be on the line. Say in some hostels, students staying alone. What do if they don't have any this thing? They have this kind of heater, and they will put it. But this is the most dangerous thing. Suppose someone has started, and in your house some kid comes, some young boy or girl comes, and he or she touches this water, he will get shocked. Sometimes this gets loosened, the whole thing gets down, and there are chances of getting this wire short circuited. So this is the most dangerous thing. People are using hanger also, sometimes hanger, wooden stick, this kind of wire. So this is a dangerous thing for getting shock in our house. Some kids, when the sockets are open, the kids, what do they do? They try to insert their fingers inside, or they take out some pencil or something, pen or something, and they try to insert it in this holes of the socket. So this is dangerous. But nowadays, I'll say, uh, here blank is available. Blank is available in market. It's a simple, uh, some small pin like this, plastic, and it's a plain plastic. So in all open sockets, you just fix it up, so no kid will touch it. No kid will insert any finger or any metallic things in the socket pins, because one socket will be having live supply. So this one has to avoid it. One has to take care of it. So now in so many offices, even maybe even your house, office, college, anywhere, you use of multiple this plug pins. So sometimes, if this pin is not properly inserted, if the load is more, if someone is uh, taking this out, suppose someone crosses this floor, and in his leg the wire comes, so naturally this will come out. But if it is coming halfway, then there will be sparking and it will cause fire. So one should avoid this kind of things, because this once it is situation is like this, there will be spark, short circuit, and fire. And suppose it is in a room where nobody is there, you are in some other room, and suppose in evening, suppose college, let's say example of college, something is like that, few lighting is there, and this is situation, people have not switch off their installation, then there will be fire. In so many offices also, you must have seen that at night 2 o'clock, 3 o'clock, fire has taken place. It is not only because of this, but such kind of things, or short circuit of the things, heating of the cables, like that. See, this I'll show you in my case study. I cannot show you right now in this thing, but in our GB Jetco 66 kV substation Changa, there was a shutdown in on some of the equipment, say breaker city. So that one technician asked one helper to bring discharge door, not ladder, discharge door. So he came with a discharge door, but it was in a vertical condition. Then there was some stone here, so he got stuck with the stone, and the live wire touched with this our bus conductor, which was live. So he got shock and he made with an accident. Another accident was of one junior engineer in Kurjan substation, Kurjan 132 kV, now 220 kV. So work was going on. So the junior engineer himself took out the ladder, and he came with the ladder from the store just to help his people, and he got electrocuted. Electrocuted means fire, death. Electrocuted means crash, death. So such kind of things should be avoided. You should know that these are the lines, dangers, line having electrical power. You do not, because electrical power one cannot see. So people who do not know electricity, they do not know the danger of it. So they come across certain things. Some vehicle also having some kind of load. They just cross some our overhead lines, and they get shock also. Again, the same thing. Here, see, a proper size of pin should be inserted in socket, and there should not be some repairing things. Here, if suppose insulation is broken, damaged, here insulation is broken, then there are chances that this both wire will get shorted, you know. So once it is shorted, there will be flash and there will be problem. So uh, here I'll tell you one thing. In paper also you must have heard that somebody's mobile got heated up and there was a blast. So the charging pin of your charger, if it is not of origin mobile and some other charging pin is inserted in your mobile, then if it is not shooting, then there will be gradually some damage will be there, gradually some heating will be there, and one day, it will get so much heat up and it will blast your mobile. So is the case with every instrument. See, in electrical, loose connection is the first thing. There should not be any loose connection. If it is a loose, there will be heating, sparking, and there will be a flash. So always electrical connection has to be tight fit like. It should never be loose. So now, see, after knowing so many hazards, electrical hazards, people are working. So when people are working, they are working with safety. So what they have to do to avoid the electrical accident? Know the risk hazard. Risk hazard means in particular equipment or particular area, particular plant, what kind of risk is there, you should know. If you are not knowing, ask someone, what is the risky over here? What is the risk over here? Hazard potential means what can go wrong. What are the dangers in particular equipment? So if you are knowing or if you are reading the manual of that equipment, or if you are having knowledge of that your substation or electrical all equipment, then once you know, naturally you will avoid the dangers. You will avoid the measures which can lead you to the accident. Know your safety operating procedures. What is this safety operating procedures? Means everything has got their own procedures. Own procedures means I'll give you a simple example that once you are charging your say mobile, then mind well, in you are inserting your charger in socket, then don't insert the charger when the switch is on. Mind well, when the switch is on, don't insert your charger. And the same way, don't take out your pin from mobile when the charging is on. See, these are the safety operating procedures. This is a simple example I gave you because everybody is having their mobile, their charger. So in on condition, don't don't insert, and as far as possible operate everything in off condition. If you pull out, if you insert in on condition, and if it is loose, there will be spark or damage to your equipment. So in every equipment you have to understand the safety operating procedure. In breaker also, I'll show you breaker again. Go back. See, breaker. See, the breaker just now. See, if you can see here, it is in out position. Out position. If the breaker is inside, this will be inside. I mean, it will be inserted. So when you are making breaker in, you have to see that our DC is on. DC circuit is on. Then by pushing this button, you will find that trip circuit is healthy. You have to check every time trip circuit should be healthy. If trip circuit is not healthy, then if there is a some problem, the breaker will not trip, and the breaker if not trip, it will blast. It will not only blast, it will damage all the panels. So there is a procedure that first, when the breaker is out, you make the breaker on and off in test position or outside. Then you insert the breaker. Then there is a plug over here inside this thing. So you have to make the plug fitted in its junction, and then you have to again test it. Then you have to see that breaker must be in off condition. This is a interlock. Breaker must be off position. If you insert the breaker in on condition, there will be heavy blast, and there are number of accidents in GB or Jetco because of inserting such kind of breaker in on condition. Earlier there were very less interlock. Nowadays there are less chances because now interlocks are such that you will know the breaker is off condition, then and then you can insert. So interlocks have been developed. Okay, now safety awareness. As I told you, you should be aware of all electrical items, all electrical instruments. So electrical material, electrical installation, motor, fan, breaker, your electrical lines, everything you should be aware of safety. Then most important is this: do's and don'ts. Do's and don'ts. So everywhere there is a do's and don'ts. So see, if I want to insert my breaker and start supply, there are system. I have to follow the safety operating procedure. I have to know my interlocks. Then do not mean you one should not bypass the interlocks. Bypass means direct कर देना. Without switch and fuse, if you make the direct connection, then without protection, you will be in trouble. So every equipment, your phone also have do's and do not. Say some few years back, someone told me, साहब आप मोबाइल में कुछ भी करना मगर उसके सेटिंग फैक्ट्री सेटिंग है उसमें मत जाना अगर फैक्ट्री सेटिंग में गए और कुछ किया तो आपका मोबाइल लॉक हो जाएगा. This was some 10 years back. So everywhere one should know the do's and do nots of all the equipment. If you know the do's and do nots of equipment, you will be safely operating your equipment. So every electrical installation has their operating manuals. So from operating manual, say washing machine, there's your garganti or your AC. There are always do's and don'ts. So you have to follow it. You have to understand it. So as soon as you are procuring or possessing or installing some electrical installation, first go through your reading, go and read your manual, operating manual or manual. So if you know this thing, you will be saving yourself, you will be saving equipment. Follow safety procedures. Again, the same thing, operating follow. Use of proper PPE. What is PPE? It is a personal protective equipment. I'll show you later on. So while doing any electrical work, as per the work, you have to use proper PPE. Now ensure complete isolation. For any work on electrical system, you have to switch off the supply, you have to isolate it, and you have to discharge whatever the charge is there and properly. This is the method. Anywhere if you want to work, make sure that you have cut off the supply. After cutting off the supply, you make sure it is isolated from both the sides. Then, even if you isolate, there will be some charge in it. You know, our ceiling fan, there is a capacitor inside. So even if you switch off, if you switch off and fan is not working, then if you touch the capacitor, there will be charge. You will get mid shock. It is the same thing in battery also. Battery also there is a charge, so one does not have to touch immediately. For that, you have to get it discharged, and after getting discharged, all the phases have to be earthed properly. So now some good habits, bad habits. See in industries, some people something once they do work here, they open out the this top cover and put it somewhere. This is not the right way because some tools may fall in it, it may get short circuited. So the protection covers are always required. So welding machine generator with guard. This guard is see here there is no guard. This is a guard cover. Guard cover means there will be fan. So if fan cover guard is open, someone will uh, here. It will touch or he may fall on this thing and he will get some injury to his body. So wherever these covers are there, guard is there, it should be in its position. Again, see here, no cover, no cover, no cover. So such fan, this is a fan cover and guard again, and this should be sealed. This should be sealed. It should not be open. So all machineries, electrical machineries, they should be covered. So grounding is earthing. Protection from electric shock, normally secondary protection measure. A ground is a conductive connection between electrical circuit or equipment and the earth or a ground surface because it creates a low resistance to earth. So whenever there is a fault, when there is a short circuit, the fault current will flow from the equipment or structure to the earth, that is ground, without having further damage. So again, this kind of thing we frequently see at so many places. This will lead to flash, spark, and fire. So one has to use such plug pins like this. And another thing I'll tell you, don't rely on the switches also. Suppose sometimes you may switch off, but actually the link between this might not have been separated. So don't rely every time on this thing. When there is an important thing and you have to work after this thing, take out the plug pin or plug top. Take out the plug top and work. Don't rely on this thing. What are the PP? Personal protective equipment. That is a safety helmet. Every worker or every person working should have safety helmet, safety shoes. Now safety shoes are different in different industry. In electrical safety shoes, then industries, this mechanical, there is a metal toe on the front side. Then chemical industry, it should be not slippery. Rubber hand gloves of the proper capacity. Rubber hand gloves for electrical, it is a must. This is a must. Insulated tools, your spanner, your plier, your screwdriver, they should be all insulated. Safety base, this is for the transmission line workers or substation line workers, safety base. Earthing rod, then operating rod. Live line detector. This live line detector is something to know whether the line is live or not. This is again a very beautiful instrument. It can save any person before going to work. If he is checking with this thing, then he will know that whether the equipment is live or not, whether the power is cut off or not. So this can save him. Rubbermaid, rubbermaid. So on. Always your shoes, rubber shoes will save you from earthing. So naturally, fault current will not flow through your body. You will not get shock. So rubber mat in all the substation, it is always there. I'll show you pictures later on. See, these are the all insulated tools and tackles, right? So these are the steps ABB had written. What are the steps to follow while working? So you can't read it here, but these are the things. So this is again a rubber hand gloves, right? So this was displayed in ABB. See, again, as I told you, safety helmet, safety shoes, rubber hand gloves. Then this is a radium jacket for the people working at night or that thing. Then this is a safety belt. It's called body harness also. Then sometimes when you are working in a battery room, you should have a goggles. When you are working on a cement work, you should have a mouth mask also. So these are all PPE equipments. So this is again say demo statue at 400 kV line site. We used to go there. I had taken this thing photograph in front of me. So this is a demo at 400 kV line in Rajasthan. This KEC company, KEC International Company, were constructing 400 kV line, transmission line with towers. So this is the at the site. Say in tower, when some people are working, as I said, this is a safety belt, and again this is a clamp, anti-grip clamp. So you can go up, but even if something goes wrong, this belt will not allow you to fall down. So this safety grip and this safety belt will save you. So even if something goes wrong, you will be saved because of, see, here, can you see this thing? Because of safety belt, it is being hanged. You will not fall down. Otherwise, from 20, 30 meters up, if you fall down while working, you will meet to death. See, this is a earthing rod. Earthing rod being used for earthing. And this is a clamp. And this is the earthing cable. It's a copper cable. This is the panel body earthing. Here, this is a common earthing point. So this earthing rod will be used in switchyard as well as any equipment when there is a shutdown or when someone wants to work. So this is called rubber mating. So when the operator is doing removing the breaker from panel to outside or inserting breaker in, suppose something goes wrong, some flash is there. So this rubber mat will save him from getting shock. So okay, and this material of this thing, this is a operating rod. It is a fiberglass material, FRP material. So this is fully insulated, highly insulated. So okay, now when you want to work, what you do, separate the work area from all possible sources of power supply. How can you do it? You have to cut off the switch. You have to cut off the switch by handle or anything. By opening circuits. You first open the circuit breaker, it is automatic, then isolator, that is switches you do manually. Then, suppose when you have opened it, then with padlock you lock here. With padlock you lock here, so that someone else may not come and close the switch. If someone comes and by mistake he closes the switch, the power will be there. So this is again a added safety lock, safety padlock. Check the essence of voltage at source on site on each conductor and apparatus involved. So now we have, once it is isolated, we have to check here whether there is a power voltage is there. So we have to check it. So with live line detector, you can check from a bit distance. You can keep your live line detector here, and then live line detector will say there is a power here, there is a power here, there is a power here, or no power. So live line detector from some distance, you can check it. You don't have to touch and see. If you touch, if there is a power, you will get shocked. So from little bit distance, you can know. So this is some sort of this is a touch live line detector, touch. So this is an instrument not used in India. It is outside India, but he is touching it and knowing whether the power is there or not on each conductor, each phase. So after confirming that there is no power here, what he is doing? He is doing a earthing of this phase, earthing of this phase, earthing of this phase, three separate discharge rod or discharge system and connected and made to the common earthing point. This is the common earthing point. So now it is safe to work. So even the power comes in the system, it will be earthing is there, so it will trip. So persons working on the line will not get shock. Then you put something barricade. Barricade means no one should enter this area. Then this is a danger plate. This is a warning sign. Nobody should enter here. Nobody should make it on. अच्छा हेतल मैम is the timing okay or from hello
Yes, sir.
is I'm going okay or you are we are finding short of time?
Yes, sir. Within 5-10 minutes, you can.
Oh my God. Okay. Anyway, I'll go bit speedy.
Yes,
So let power be clear. Test it. Once we've isolated, test it and ground it. This is a say again. The isolator you have to make this isolator you have to make sure it is open. Then test it. There is no voltage. See here this emitter selector switch. After breaker you made off, make sure with the MPS selector switch, R phase, Y phase, B phase, it will show zero here. So once it is zero here means all the breaker pole have opened it. So it is fully isolated. Can you see here 0 ampere? This is ampere selector switch. So R, Y, B and off. Three positions are there. You just move on. You want R, then you move here and make sure it is a 0. So then you can ground it. So this is the discharge door. Where whatever the charge is here, with this discharge door, you can discharge it. This cable is with earth. Safety advice, as I told you, do's and do nots. Why someone will get shock? It is electricity, it's a part and time. As per this thing, how much current flows for how much time. Prevention, keep away, ground it, and this is a our just like ELCB, earth leakage circuit breaker. It will prevent you. Say once you get the shock, shut poster should be there. It should be breathing and then getting help. Again, this CPR is called cardiopulmonary resuscitation. So once someone gets shock, this is a procedure to follow to make him alive, make him alive if possible. Now, this is the most important. See, if more than 3 million ampere current flows in your body, then there is a painful shock. As it is a electric, our alternative current line. So once you touch it, you will get a jhatka and you will leave that wire or circuit. If it is more than 10 milliampere, our muscles will get contraction and danger will not be there. But suppose if it is a more than 30 milliampere, our lungs will get paralyzed and temporarily there will be some problem. But more than 50 milliampere is a ventricular fibrillation. So heart may get dysfunction and usually fatal. Fatal means death. So more than 100 milliampere to 4 ampere, certain heart fibrillation and fatal, 100% fatal. So over 4 ampere, heart may get paralyzed, severe burns may be there by more than 600 watts. So current and timing is important. This is what in our I show you. This is a clamp. It will not allow you to fall when you climb the tower. Electrical burns. There will be a lot of burns. Then first aid should always be there everywhere. So this my presentation is over. I wanted to show you some video, but we are falling short of time. So anyway. So is there any questions? Is there any question? Can you hear me?
Yes, sir. Hello.
Haji.
Sir, what is the meaning of the potential injury?
Potential injury means एक simple बात है कि you have got one bucket water in your house. If you have got one full tank on overhead on your house, where is the more potential? Where is the more potential? In the tank, water in the tank, right? It's a potential hazard where there are all the chances of getting more damage. This is a potential hazard. You got me? If bicycle stuck with you, it's a less potential. If a scooter stuck you or hurts you, it's a bit more. But suppose if a truck hurts you, it's a big potential in risk. So that potential hazard is big or more in a truck accident. Any more? Any other question?
No, sir. No questions. Other than
Students, I'll tell you, as I already told you, electrical safety, right from today only, be alert, try to know your risk hazards, try to know where you should be alert, and always, first of all, know know the do's and do nots. Everything, do's and do nots. And if possible, I can take you to any substation also sometime. I don't know, possible or not, but once you see some substation, you will understand more what is the substation. Lines you have already seen 11 kV line, 66 kV. Nowadays in India, 765 kV lines are also constructed. One lane is you're passing through near Vagodia also 765 kV. So the big towers. But one should know. And I'll tell you, most difficult job is electrical. You know, chemical is also difficult and dangerous. But this particular acidic chemical. So you're a bit aware, not fully aware, which are the chemical dangers, but you are a bit aware that okay, chemical we don't touch, but electricity you can't see at all. So naturally, it's the thing which you cannot see is the most dangerous. जैसे बोलते हैं ना मदारी के वो ठेले में 10 सांप रखे होते हैं और मदारी बोलता है कि इस सब सांप का जहर मैंने निकाल दिया है आप उसको निकालो बाहर निकालो विल यू टच इट नो विल एनीबडी विल डेयर टू टच दैट एनी ऑफ द serpent नो व्हाई because you never know whether the Madari says is true or wrong, but we should be aware. So we want that. So is the case with electricity. So mind well, create electricity as a energy, but if you don't create it, then naturally it will bite you, it will hurt you, it will damage you. You know. Anyway, I've seen accidents of my own people, and throughout my career, I've been giving lectures for safety in construction of transmission line, substations, industries also, and I accepted invitation from Madam Hetal Prajapati just with the reason that even if your university pays me or doesn't pay me, but because of my lecture, if someone gets benefit or if he conveys this some say certain aspects of my this lecture to someone and he's saving himself from some shock, then it is worthwhile. I'll be happy.
Yes, sir. True, sir.
So some videos were there, but again, we're short of time, and we may make it some other day, sometime also. And this is very useful. Say, without knowing if you drive a car, without knowing the gears and everything, you will meet with an accident. If you don't know your brake, you will meet with an accident. So brakes are always important to know how much to brake, when to brake your vehicle. This is same thing with electricity. If you do not know, if you are not aware, then naturally you will put yourself into danger or someone into danger. So saving our life, saving our people's life, saving our equipment, we must be aware. So Mr. Bhagat, anything else?
No, sir. Nothing.
Mr. Talati, Apurva?
I think they are on the way to home.
Okay.
So,
Madam Hetal?
No, sir, there is no questions from our side. Now, I would like to say thanks on behalf of our university for giving this very good information to our students. Thank you very much, sir.
Okay, but
Selector sir, please.
and another thing I would like to know, please let us have feedback from your students. I'll be happy to
Sure, sir.
receive their feedbacks, and depending upon them, we may deliver them a better lecture, better training next time, right?
Sure, sir. Yes. Thank you, sir.
Okay, thank you, thank you.
okay, so myself, Rishi Bhagat,
Yeah.
on behalf of Parul University, I am very much thankful to you, sir, Mr. K.D. Kavaiya, sir, for giving his valuable time and focus on the topic of electrical safety. Thank you very much, sir.
Okay, thank you, thank you. So can we conclude it?
Yes, sir. You can leave, sir.
Okay, thank you.
Yeah, thank you very much.